Hello everyone, a very warm welcome to this video. In this video we are going to talk about Hadoop ecosystem. Now we've seen what is Hadoop, what is HDFS, MapReduce and Yarn, and in this video we are going to talk about what is ecosystem. Well, the easiest way to visualize ecosystem is the way you have core iOS or Android and on top of it you can have apps. Very similarly at core, Hadoop is HDFS, MapReduce and Yarn, and on top of it you have ecosystem projects. So what apps are to iOS or Android, ecosystem is to Hadoop. So in this particular video, we are going to talk about 5 ecosystem projects: Scoop, Oozie, Pig, Flume and Hive. Now this is just a sneak peek preview of ecosystem projects. There will be separate videos for each and every ecosystem project that we'll be talking of. And there is a lot of hands-on covered in this particular course about ecosystem projects. So let's get going. So the first ecosystem project that we are going to talk about is called as Scoop. As soon as you learn Hadoop, the first thing your manager is going to ask is typically, hey, we have some data in Teradata or Oracle. Can we put that into Hadoop and do some analysis? If that's a use case, don't start writing your own code because you have Scoop. Scoop is a tool that is used to import data from SQL databases to HDFS. It's an open source tool developed by Cloudera. It can do SQL to Hadoop as well as Hadoop to SQL. Uses JDBC to talk to the database. Can import a single table or all the tables in the database. In fact, as a developer, you can specify a where clause and make sure that whichever data is satisfying a certain where clause, only that data could be imported. It can directly create Hive tables. We'll be seeing Hive in a separate video. What Scoop does is Scoop takes commands from a user, analyzes those tables and generates Java code to get that data. After Java code is generated, a map-only MapReduce job is run to import the data. By default, 4 mappers are run to get the data. Let's look at a simple example. There is a lot of hands-on on Scoop. We will just look at a simple example. In this example, we are saying Scoop list tables, username Ted, password Ted. Connect JDBC MySQL, your db.database.com, that's your URL, DB name. So in this particular case, we are actually connecting to MySQL database and seeing the list of tables in the training DB. So that's a small sneak peek of what exactly Scoop can do. And now let's talk about ecosystem project number 2, that is called as Oozie. Not all solutions can be attained within a single MapReduce program. At times, output of one MapReduce program would have to be given as input to another MapReduce program. And Oozie does exactly that. Oozie is a workflow engine that runs on the server and it facilitates functionality like run program number 1, take output of program number 1 and give it as input to program number 2. Oozie is not only restricted to MapReduce, but it can also do Pig, Hive and Scoop jobs. Jobs can also be scheduled to run at a specific intervals. So basically, Oozie is a scheduling and workflow engine for Hadoop. Oozie workflow is a set of actions to be performed in a particular sequence. Oozie workflows are written in XML, has 2 types of nodes, control flow nodes and action nodes. Control flow nodes define the beginning and end of a workflow, and action nodes is where the real execution happens. A small example, in this Oozie XML, what we are doing is we are trying to run a workflow called as inverted index. We start with an action called as inverted index, and inverted index we are saying that we would like to run a MapReduce job, the IP of job tracker name node and the classes. And if it's all good, we go to OK tag. If there is a problem, we go to error tag and let's say notify everybody that the job has failed. So in a nutshell, Oozie is a workflow and a scheduling engine for Hadoop. So what we've seen so far is Scoop and Oozie. The next ecosystem project that we are going to talk about is Pig. Now, writing MapReduce programs needs decent amount of Java knowledge. This entry point of learning Java would have restricted a lot of functional experts who would need to query data. That's where comes Pig Latin. Pig Latin is a data flow language with a simpler syntax. So you don't really have to write Java code. You can write code in a script which is more English-like, and Pig compiler or interpreter will take care of converting that to MapReduce. So this is how it works. So on your client, you write your code in Pig Pig interpreter will convert that to MapReduce and submit it to the cluster. So there is no additional setup required on the cluster side for Pig. All you need to do is have a client installed, write your code, and it's all done. There is no need to learn Java. Now, this example shows a small Pig script. Here what we are doing is we are saying students is load students.txt as id name percentage. So student.txt is a file and each record has id name percentage. Distinction is equal to filter students by percentage greater than 75. So any student who scored more than 75 would be fulfilling this criteria. Then we are saying order distinction by percentage in descending order, that will order the students in descending order, and finally you can store the rankings. In Pig, a single data element is called as atom. Collection of atoms is called as a tuple, which is as good as a row in a table. And collection of tuples is called as a bag, which is as good as a table in relational world. So typically Pig would load a data set in a bag, then creates a new bag by modifying the existing one. In the example above, student file is loaded in student's bag, and a new bag called distinction is created with percentage above 75, and so on and so forth. So with Pig, if your data is really majorly text oriented, there is no good reason to write MapReduce. You can do all of it in Pig. So if I have to get data from relational database, it is Scoop. If I want to write workflows, it is Uzi. If I want to write data flow or scripts, it will be Pig. The next ecosystem project that we are going to talk about is called as Flume. Flume is a service that basically lets you ingest data, typically log files, into HDFS. It's defined as distributed, reliable, and available service for moving large amount of data as it is produced. It's an open source service developed by Cloudera, and these are the goals. Well, on a very high level, this is how Pig works, Flume works. So you have your Flume agent. There is a source component that reads from the web server, and the source component would push that to the channel. Now channel is a buffer that would get filled, and then once the channel is full, it basically dumps the data to HDFS. Flume is extremely popular when it comes to ingesting real-time logs. So these are certain definitions of each and every component in Flume. We have a separate video on Flume, that's where we'll cover all these details. So this is all about Flume. The next ecosystem project that we are going to talk about is Hive. Hive was developed at Facebook, provides a SQL-like language. Like Pig, it generates MapReduce jobs that run on the cluster. Hive has a layer of table metadata definitions. We'll be covering that in the Hive video in detail. So let's see how Hive works. So you can typically write your SQL queries in Hive, and they'll get converted to MapReduce and get submitted to the cluster. This is how Hive works. Couple of sample queries. You could create tables and write select star from students, show tables, and so on and so forth. So Hive is basically nothing but SQL on Hadoop. So a quick summarization. In this video, we saw ecosystem projects. So ecosystem projects are equivalent to apps on Android or iOS, you can say. So here ecosystem project is apps on top of Hadoop. So we saw ecosystem projects like Scoop for importing, exporting data from RDBMS, Uzi for workflows, Pig for data flow language, Flume for log files, and Hive for SQL on Hadoop.